Okay, the concept of matrix is very easy, like the concept of vectors. A matrix is a set of vectors, and a vector is a set of data where each data has a single position. Or a matrix is a set of data where data are organized in rows and columns. It's very easy. And you can use these concepts, and especially the concept of matrix, to reply the reality in the world. Okay? So let's see a second example. Let's see this second example. The statement. Build a program that loads a 3 by 2 matrix, then read an integer and determine how many times this integer in the matrix. So, the semantic analysis. Remember what is load? I'm sure you remember, but let's write again. What is a 3 by 2 matrix? Let's write again. What is read an integer? What is determined in the terms of the computer programming? And what does how many times? How many times mean in the computer programming world? Load is read a set of data and store in the 3 by 2 matrix. Okay? What is a 3 by 2 matrix? Okay? It's a set of numbers, in this case, organized in 3 rows and 2 columns. Read an integer. Read an integer means read a number without decimal point and without, of course, decimals. Determine is confirm a number has an special condition. And how many times means the quantity about a special condition of a number. Okay? Remember, you have to understand the semantic analysis. If you don't understand the semantic analysis, you really don't understand the statement objective. And if you don't understand the statement objective, be sure you can do a program. It's impossible to do a program if you don't understand that. So let's see the Ipo analysis. Again, we're going to write the general instructions and then we're going to specify the instructions. So first, we have to load the 3 by 2 matrix. Okay, this is the first. This is the input. Second, we have to read an integer. Third step, we have to determine how many times is this integer in the matrix. And the number 4 is the output. You have to show the quantity this integer is in the matrix. Now, let's see the specific instruction of general instructions. So let's see. Load the matrix. We need to use, in example 4, it's possible to use any other loop, but we are going to use a loop for, let's use again R as the variable for the row, equal from 1 to 3 with a step of 1. Then for column is equal from 1 to 2 with a step of 2. Then here read a number and story in matrix M, row R, column C, and that means N4 and N4, right? Okay. Now let's see, read an integer. This is the integer we're going to find. So we only need to say read integer to find. Let's use this number, it's very clear, of course. Now determine how many times is this integer in the matrix. So let's use again the for loop and for R for rows from 1 to 3, step 1, and then for C for columns from 1 to 2, step 1. And ask if matrix M in row R column C is equal to integer to find, then as we are going to count how many times, we need a variable here in this place. Let's name it like counter. Counter equal to 0. So if this condition is true, we need to write counter is equal to counter plus 1. And if N4 and N4. I'm sure you know that the number 4 step is very easy. It's only write counter. Okay? Okay. Now let's see the call test. Remember memory and display, right? Okay. We need a matrix. But in this time, this is a 3 by 2 matrix. That means this is a matrix. The name is M. I think it's a good name. Row 1, row 2, row 3, because this is a 3 by 2 matrix. That means, remember, 3 rows, 2 columns. Okay. And the columns are here, column 1 and column 2. Very easy. Now R for the rows, C for the columns. And counter, and of course, the integer to find, right? Okay. Pick a number and write and store it in matrix M, row R, column C. Suppose we receive number 4. So this 4 is coming here. Why? Because this is the row 1, column 1. N4. That means increase C in 1. Now let's see. Read a number and store it in matrix M, row R, column C. Suppose we receive number 5. This number 5 is coming here. Why? Because this is the row 1, column 2. N4 and N4. Row increase in 1, column back to 1. Now, read a number. Suppose it's number 6. Read a number. And study in matrix N, row R, column C. So this number is coming here. Why? Because this is the row 2, column 1. N4 increase C. Read a number. This is number 3. This is an example. And this 3 is coming here to this place. In this place, you store number 3 because this is the row 2, column 2. Okay? N4 and N4. So row increasing 1 and C back to 1. Now, read a number. Suppose is number 3. Again. This 3 is coming here. Why? Because this is the row 3, column 1. Suppose after N4 and step 1, suppose we read number 5. This 5 is coming here. Why? Because this is the row 3, column 2. So, step number 1 is finished. Now let's see. Step number 2. Step number 2 is very easy. Read integer to find. This is the name of the variable. So we're going to read a number here. Suppose we want to find number 3. Okay? So this number 3 is coming to the variable integer to find. Right. Now let's see step number 3. I'm going to copy because I'm sure you will understand very easy this concept here. So let's see here. Okay, number 3. Now let's see. Counter, this is a variable, begins in O. Right? Now, R begins in 1, C begins in 1. Ask if matrix M, row R, column 1, column C, matrix 1, 1, this 4, is equal to integer to find is 3, that is false. So, and if N4, that means increase here. Ask if matrix row 1, column 2, this 5, is equal to integer to find, that is false. So, and if N4, that means, and N4, that means R increasing 1 and C back to 1. Ask if M, row 2, column 1, is 6, is equal to integer to find, that is false. So, and if N4. Now ask if matrix M, row 2, column 2, B3 is equal to integer to find, that is true. So counter is equal to counter plus 1. And if N4 and N4 are is increase in 1 and column back to 1. Now ask if matrix M in position row 3 column 1 is equal to integer to find that 3 is equal to this 3? Yes. So counter is equal to counter plus 1. And if N4, that means increase C in 1. As matrix M, row 3, column 2 is equal to integer to find 5 equal to 3, that is false. So this is the end of the third step because the top for R was 3 and the top for C is 2. Then let's see the step number 4, write counter. So we only have to write counter. Counter is equal to 2. So let's write 2. Now let's see. You read 6 numbers organized in 3 rows and 2 columns. Then you read a number you want to find there. Then you put here 2. 2 is the quantity of this number you want to find in the matrix. It's 2 times. You reach the objective. Yes, of course, you reach the objective.